Hi, I'm Adam, and today I'm joined by my colleague James, and we're going to talk about observability for video playback. As video platforms scale, teams rely heavily on observability to understand how their systems are behaving. But video playback introduces a different set of challenges, where success is measured by viewer experience and not just system health. In this conversation, we'll look at how playback observability fits into the broader observability landscape, why it complements general observability tools, and how it helps teams better understand and improve the experiences they deliver to viewers. To get started on question one, how does video playback observability fit into the broader observability landscape?
Yeah, I mean, the concept of observability in the enterprise IT space is quite well understood now. It's a concept whereby you can capture data from applications and services to then alert you of issues and debug and find problems. And that concept is quite well understood. But those tools are general purpose. They're not tailored towards video playback and video streaming. And so I think that's where there's an opportunity to improve the types of data, the quality of information that video streaming teams have when it comes to observability. So for example, if you are using general purpose sort of application monitoring, that's quite different to the type of information that you need for video streaming. The application monitoring may be able to tell you that there was an error, but with video streaming observability, you'll be able to tell there was an error during an ad and it was on a certain device, maybe an Android device using an ExoPlayer version, for example, and it was during an ad and this was the specific error message. That type of granularity is crucial. The same on the server side, if you're using tools like Video Encoder, for example, there are specific error messages that happen during encoding which are tailored to video-specific workflows that you need to understand, which currently general purpose IT observability tools are not providing you that granularity you need to solve problems in the video streaming space.
Now for my next question, what questions do video teams actually need answered when something goes wrong?
Yeah, I mean, that's a crucial question, because if something does go wrong, the speed at which you can respond to that is absolutely essential. And I think what helps video teams to prioritize is understanding the impact of an issue. For example, is this issue related to just users on a specific device type, and how prevalent is that device? Is it the most popular device? Your smart TV is affected, your Samsung TV app is affected. That's pretty crucial. Then secondly, what area of the application or the stream is affected? Is there something that's impacting your monetization, for example, that could be directly causing you to lose revenues? Or are your viewers dropping off and abandoning the stream and not coming back? Or maybe you're streaming live sports and obviously there's no tolerance for downtime or errors in a live sports streaming scenario. So I think understanding the scale of the impact as well as the effect on the viewers or effect on your monetization is quite crucial. And that's where the observability tools can help you with both aggregate level data to help you to see what types of devices are affected, or maybe a specific CDN is affected by an issue, for example, but then also being able to go down to a very, very granular session level detail to see within a viewer streaming session, is it the ads portion of the playback that's impacted or the main content, for example. And those tools are absolutely crucial to help video teams both prioritize working on issues, but also understanding exactly where they need to focus to find the root cause of what's going on with their service.
So the next question I have is around our evolution from analytics to observability. What made that change possible for Bitmovin?
Yeah, absolutely. I mean, I think if you look back kind of a few years in terms of what teams were doing, they were taking quite a reactive approach to understanding quality of experience and improvements they could make to their service. They were looking at dashboards and loading dashboard screens, and it was very kind of dashboard and metric centric. What we've seen now is a transition, particularly with the dominance of live content and how important live content is and how engaged viewers are with live sports, for example. Streaming services and their teams want to be much more proactive when it comes to understanding quality of experience, any issues when it comes to understanding monetization and viewer engagement as well. So we had changed our product, and we are changing our product to reflect that transition within the industry towards more proactive understanding of quality of experience, of engagement, of monetization, and also the transition that the industry has made towards live streaming and the prominence of live sports and how much revenue there is tied into live events and live streaming. So we've been doing some of these things for a long time. For example, providing our session level analysis, our top errors and error stack trace information that you get from video players. So that had already been there. So in essence, we had been doing observability for quite a while, but I think what's changed now is the immediacy of data has really increased, and you couple that with AI tooling as well. What we are really doing is providing observability, but tailored towards video playback. And the analytics product name didn't really reflect that aspect of the solution, and so we changed it to observability, and the response from our customers and on the market has been really great. I think people really understand much more clearly what we do, and it helps us to have really good conversations with the right teams within streaming services who can take advantage of this real-time data and observability.
You mentioned AI there, which is perfect. Now, where does AI realistically fit into video observability today?
Yeah, it's becoming a core part of it, right? I mean, it's kind of obvious if you have a massive amount of data, and we're capturing billions of samples of data every month, over 70 billion samples captured and stored currently by our observability solution. If you're capturing that much data, inherently it's very difficult or even impossible for humans to analyze all of it, right? So it's a natural fit for AI. But I think what we've seen with using LLMs and new analytics, tailored observability AI agents on our MCP server is we can give end users much better access to their data using natural language rather than them needing to dig through metric charts. So that's quite a key thing when it comes to the user experience and broadening the range of users, being people who are working for video streaming services. The range of users who can get access to data and understand it is much greater because they can now use an LLM to talk to the data set. So that's quite a crucial change in the user experience, which we've pioneered and introduced. And I think when it comes to the data analysis, we've done some really cool stuff around, for example, AI smart alerts, where we can detect anomalies in the data. For example, you're seeing an unexpected spike in startup time or rebuffer percentage, which is outside of your normal ranges, and being able to proactively tell you about that. So I think AI is an absolutely natural fit into observability, and some of the tools we've built, like our MCP servers, our AI assistant, our AI session interpreter, are really helping teams every day to do their job better.
More on the topic of AI, why did Bitmoven build an AI agent as well as the MCP for observability?
Yeah, really good question. So the two are kind of closely related. So the MCP server is a way to give large language models and AI models access to the data from our observability product. It effectively gives them an easy way to ask questions of the data and get answers about the data. So that then allows the LLMs to do some agentic reasoning, combining the data from our observability with other data sources, other information they can get. A great example of this is a query I ran recently, where I asked an LLM to find the most commonly occurring error in my streaming platform and look at the documentation for the video player that was being used to find the root cause and tell me what I needed to change to fix that error. So there you're taking data from multiple different data sources and combining it to solve a really difficult question that obviously you would need a software developer otherwise to figure out. So the MCP server enables that kind of workflow. The thing about the MCP server though is you need to be using an LLM. So you need to use it with something like Claude Code or maybe Copilot, and you've got to set that up. It's something that developers and data scientists can do, but it's not generally available. It tends to be something that requires a technical person to set up for you. But if you're somebody, let's say, working in a marketing or an ad sales team or a product team at a streaming service, and you want to be able to use that same capability, asking questions of the data using natural language, it's much simpler if you can just open a web page with a dashboard UI with like a nice text box with some pre-created queries for you, and you can just click around and type in what you want to know and then get the answer. So that's our AI agent and our AI assistant that we built that gives people access to their data using AI, using LLMs but from a nice, easy to use dashboard interface. The MCP server, great for more technical teams or data science teams who are using their own LLMs or want to get into more detail around setting up and configuring the MCP.
Thank you for that insight right there. Of course, along with AI agent and the MCP, which have been powerful, of course, we had a lot of great feedback because, of course, it's just using natural language has been fantastic, giving our platforms easy access to their data. What is and there's another AI tool like AI Session Interpreter. What is that a part of this mix?
Yeah, great question. So the AI Session Interpreter is something that we've had in the product for a couple of years now, and we've refined and improved it over time. The AI Session Interpreter actually goes to a much more granular level. So the MCP server and the AI agent currently look at more of the aggregate level data, which you can then filter. So for example, it might be able to say what your rebuffer percentage is across Android devices over the last 24 hours, for example. Really useful information, but much more aggregated. The AI Session Interpreter allows you at the level of individual viewer sessions to understand exactly what is happening within that session. So a great use case is customer care teams working within video streaming services. They may get a support ticket come in from one of their viewers who's having an issue. They can actually find that viewer session. They can do an AI session interpreter analysis on it, and that session interpreter is going to tell them exactly what happened in the session, what was good about it, what was bad about it, why that viewer maybe has logged this support ticket, what was the problem they had. And from a technical perspective, it's giving you a lot of data about the issue and then what you can also do next to resolve it. So they're working at kind of different levels in terms of the data to provide the right tools at the right times for the right people.
Looking ahead, how do you see Playback Observability evolving as video platforms continue to scale and diversify?
Yeah, a great question. So currently we're focused on observability for video playback, but I think there's a great potential to apply some of the same principles to observability on other areas of the video streaming chain. It's, for example, totally possible to get similar granularity of data around your video encoding services or your CDN, for example, as well, using technologies like CMCD. I think being able to combine those data from those sources with the video playback data can give you some really interesting insights. Like, for example, you could take a look at how different video encoding renditions align with the download speed that viewers have available. And maybe that helps you to optimize your encoding renditions, provide a better experience, and save you cost in terms of storage ultimately. So I think bringing in more data sources will be quite crucial when it comes to video-specific observability. Then I think in terms of scaling this, the great potential is in combining this video observability with the enterprise sort of more general purpose observability platforms as well, such as the application data or the more general purpose server monitoring or user application monitoring that's available, to look at more like the end-to-end user experience within an app. How does the experience flow from authentication and login to maybe payment and monetization, and also video as a crucial part of that as well. I think that's kind of what's missing today, and where we have a lot of potential to scale the application of video streaming observability by combining it with enterprise and general purpose observability IT platforms to give you a holistic picture of what's happening for your viewers and your consumers in their whole end-to-end user journey, with video as a crucial part of that.
Thank you for all the insights and for joining us.
Cool, thanks for having me.